So the reference position at 100, 103. Then when I come back to my sub-site setup, test plan, then I have to zoom in. This one right here. Oh no, wait a minute, that's, which one is that?
It's the reference one?
Oh, there's the reference right there, I'm sorry. Let's do this. Right click, clear all. There's our reference. This is what I meant to do. So starting from the reference, 4 over, 4 down. That's why it looked like it was bouncing around before. Okay. And we go back to the prober. If I say there, so that's our reference. It should just go over 4 and 4 down. So we're going to go ahead and run this. Go to 100, 103, which I'm at now at. Hit OK, and then go to this. So why did it go there? Oh no, it should go there. Sorry. I'll show you why in a second. No, it's doing exactly what we told it to. So what we told it to do, we look at the subsites, test plan. Okay. The way WaveView starts, it started scanning down here in the lower left, so it's scanning around, and by the time it got up here, that's the first site it sees that it needs to test. Just because, even though this is the reference site, that's the first site that's going to test, and then it did these, and then it went like this.
So do you want to change the reference from bring it to firm?
No, I mean, it really doesn't matter. It's still, when it measures, it knows what site it's at anyway. It's simply a matter of, it's a function of this. If I go back to the wafer setup, and scanning. See how it says horizontal continuous? You can do horizontal stripe, vertical stripe. It's just a matter of where is the wafer origin. So what WaveView is doing is it says wafer origin is down here, 0, 0.
I see.
And it goes and it says anything to test there? No. And it comes all the way up through like this, weaving back and forth. In horizontal continuous means that when it gets to the end of this one, it moves up. That's the fastest. And around. Now, so far, we didn't have any devices at all in there, right? So it only mattered once it got up close to where the devices actually were. And since it's coming from the bottom, if we look at the sub-site test plan, what it did make sense because it's coming up from the bottom, scanning back and forth like this, and then it finally got to here, and that's why that was the first site it tested. So it did start at the reference. We were located on the reference, and it went from there to here, and then tested these and went back and forth like this, coming through the reference, ending on that one, and then saying, okay, at the end of the measurement, I go back to the reference. So at the end of the day, it tests everything. It's just how it goes about doing it. That's the most efficient way. So let's just test it one more time and make sure, now that we've said that, that's actually what it really did do. And I'm back on the reference site. Yeah, on the reference site. And say okay, and let's say do this. Okay, so it's on the reference. It went to that one. And now it's going. Now it's going to go up and this way. 2, 3, 4, and then up, and then that way.
Yeah.
And then up. There's our reference. It's now testing, but it's not done this row, so it keeps going.
I see.
And then when it's done that one, it's going to go back to the reference because it finished the measurement. So it did do everything that it should. So we could expand that now and have it do that whole square if we wanted to do that. So now why don't we do this? Let's say contact, and why don't you put the probe down and let's actually measure those 60 and see how they look without going too far. So what I recommend is taking baby steps like that because most of the time people destroy their wafer by doing something wrong and then starting right out to test every device. And, these look fairly robust, but other devices aren't necessarily. Okay, so we're down here. Let's make sure that if we go back to WaveView, just do our single measurement. Let's just run that again and make sure that we have good contact. And we do. Okay. So now, let's go back to our scripting. Now we need to write a script that will step the wafer but include the measurement. So the wafer walk was just a way to, I always do wafer walk, that way I don't mess up my devices. So the concept being, you know, come down on it, but then just come slightly off of it so you're not contacting. Instead of putting a measurement in, put in a sleep like we did here. So there's the sleep, so just it stops for a second so that you can visually see it went to the right location. So now we're going to take this, I'm just going to say Control C. Now we're actually going to do IV measurement cross wafer. And you know, I'd advise you to come up with a scheme of how you like to name things, but you can be descriptive in them. And I'm just going to paste what I had back in there, except I'm going to get rid of this. Now let's put in measurements, DCIV, the bear test, calling it IV dot, and add the connection. So now we've got a reticle loop as well as the measurement in there. So I'm going to go ahead and save that, and I'm going to save the project. I'm going to save it without measurement data because I just want the bare project saved right now. Okay, now we can go ahead and make that measurement. And so we need to be at the reference position, so I'm just going to make sure I'm there. Now actually, I should be able to hit this, and it's the same thing. I just added a position because I was, at the time I hadn't set, using this over here, I hadn't set mode, set reference die. So since I hadn't done that, I just made myself a little position I could hit here. But it's the same thing, you can see it's going to the same way. Longer term, if there's any run out, we might be off slightly. You know, we may eventually want to get right in the middle, but it should be fine. Okay, so I'm going to check. I'm going to run the script again. I had canceled out of the script. Okay, move to 100-103, which we did. Now it should be on the first one. So this is the first device. Over here on this, in wave view, unfortunately this isn't zoomed, but you can see what row and column it's on. Up. So now we have, if we were to go to the data manager, we should have 16 items in there, and we do. Now if we had done more than one test per reticle or per subsite, it would have just escalated from there, obviously. Okay, so in this case, I do want to save the data, so I'm going to come over here to save a component file, and I'm going to save the measurement data file. And you can see it put me into the training directory. I'm just going to call this IV16 site suite. Okay, so I've now saved my MEA file. If we were to look at the MEA file, it's in WaveView data training. Let's go back for a second. Here's the PRJ file, the project file. I'm going to open that with WordPad. Notepad is fine. What you can see is it's basically just a list of pointers. It's pointers to the other files, to the dev file, to the wafer file, those things. So when you open the project file reads this, and then it goes and opens these other files. So when I say, from a support point of view, when I ask you to send me the project files, what I really mean is you need to send me all of these. So you just take these, you go, just come in and take your data and all of these, send to request folder, test.zip, and then just email me that. So that's all you have to do. Very easy. And then or if when we're using the smart sheets, you're actually not gonna, you don't even have to email it to me. You'll just go in and attach it. And do you have internet access on this computer?
Yeah.
Oh, great. Okay. So that should be fairly easy to do. So once I get you set up. Okay. And then these other files, for instance, the wafer setup file, if I can open that again using like Notepad or something like that, WordPad. You'll see it's an ASCII file. You can read it, but it's not really meant for people to open and look. It's just files that I need with certain information in them. So that one's pretty boring, but so I don't recommend editing any of those because there's pointers into them knowing where to write. So those you don't really want to edit any of these. I have one customer who she likes to take the MEA file, and she knows the structure of the MEA file, and she likes to go into it with MATLAB and parse it all out and do things with it. The trouble with that is that anytime different revisions change the MEA file format, and then you'd have to know that, and I don't publish it, so I mean, the MEA file, you can see there's a lot of stuff in here. So once again, this isn't, like the MEA file isn't the place you go to get your data. The MEA file is for Waveview to store the data. Okay? So that's an important distinction to remember. Okay, so we now have data there. Let's go create a report. So let's do, for the first report, let's take a look at an XY graph, and let's do IV sweep versus wafer. Let's just do IV sweep, and then you'll see actually how that works. So the first type page here, you can put titles and things. You can see that we're doing an XY graph. But I'm going to go to the Define Data tab. And here, for the x-axis, I'm going to pick, there's our IV dot, right? And you can see that the source is data. If I picked any of these other ones, see how it says virtual? Those are virtual data objects to use to set up something in the case you didn't have any data. But I typically recommend get some data into the machine first, and then build your reports off of that. If you want to build a report and you don't have any data, then what you can do is, we could have run that same script we just did in simulation mode right here. So if you click that, it turns on simulation mode, and we could have run the entire script and come up with fake data that we could at least use to set up our reports. So that can be a useful tool, and that's where the Office Edition comes in. The Office Edition is always running in this mode, so all it can do is load existing data and allows you to set everything up, but it won't let you measure it. So it's the exact same software as what's on this machine, it just won't let you run. It's locked in the simulation mode. But it can be really useful, so you don't have to sit here at this computer and do it. You can do it in a more comfortable, you can put parallels on your Mac probably in here. Like I'm running virtual machines on mine. I haven't tried it on a Mac. I used to have a Mac, and I had trouble with some of the connecting to the USB port to put the key in, because you need to put the key in. But okay, so let's turn simulation mode off. So we're back to instrument mode, and I'm just going to come back now to, let's look at the script we just ran. We just ran the script IV measurement across wafer, and see the name of the data was IV dot. Okay, so when we go to the reports, that's what we're looking for. We're looking for IV dot. That other one was one I wrote in another script. So this one, when I click on it, it's not going to say data, it's going to say script. If I can click on it. I don't know what not sure what that's doing, but okay, so there's IV dot, and so we're going to plot V1 versus I1, And we can assign aliases to them too. So we could have called this, instead of V1, we could just call it V and I.